Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 777-300ER tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 144 Lszh localizer. Landing surround mount the cockpit for the pre-takeoff preparation of the BBG simulation Microsoft Flight Simulator X Boeing 777-300ER. I'm going to start showing the cockpit instrument displays and the functions of the Boeing 777-300ER aircraft. I'm going to start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the barometric pressure above the barometric altitude above the sea level, and the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot and flight director system panel, the vertical rate of climb at the descent of the aircraft is tens, hundreds, and thousands of feet per minute, with the trigonometric angle in degrees. Also, we have the radio altitude above the ground level, the magnetic heading and track, the magnetic north pole, and the true north pole and magnetic variation depending on where we are in the world. We have also the Lszh localizer, the altitude indicator with the artificial horizon, the pitch ladder in degrees and the back angle in degrees. The Lszh localizer, the horizontal and the vertical glide slope needles with the Lszh localizer. Crossbars for manual or automatic guidance of the aircraft, the flight director for manual guidance of the aircraft with the crossbars, and also the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode annunciator with the autopilot and the auto throttle later and vertical navigation modes. We have also the navigation display. The navigation display that displays the GPS position of the aircraft, the inertial reference position, the terrain and weather reflection from the weather radar. You can see the red, green, and yellow reflection of the terrain map with the airport waypoints, navigation aids, ADFs, and DPs. Display also the magnetic north or true north pole on the next waypoint, which is going to be overflying the wind direction and speed. Also, we're gonna use the flight management computer. I'm gonna show you here. You can see here the primary flight display, with the flight mode annunciator, the navigation display, the autopilot and flight director system panel, the upper and the lower ACAS and indication and crawler system display, and the flight mode, flight management computers. So I'm gonna show you how to use the flight management computers to create a flight plan or a route or a flight path for the aircraft, a complete flight plan from takeoff, climb, cruise, descent, approach, and landing. So we're gonna make a complete flight with that. I'm gonna input all the data of the aircraft for takeoff. That includes the weight of the aircraft, the takeoff gross weight. That includes the empty weight plus the passengers, plus the cargo, plus the fuel on board. That includes the trip fuel, the reserve fuel, and the taxi fuel. We're gonna have the mean aerodynamic chord of the forward winds calculated using the flight management computer, using the center of gravity of the aircraft that transverses the center of gravity of the aircraft as a reference, and also this is gonna give us the horizontal tail trim stabilizer position for takeoff, then for climb, cruise, descent, approach, and landing. So we're gonna have the horizontal tail trim position it automatically using the other trim, or we can do it manually, but we're gonna have the calculations for takeoff using the flight management computer and all this data, the takeoff weight, the flaps we're gonna use for takeoff, and the runway. We're gonna have the runway conditions. So we're gonna input all the data of the runway that we have stored in the flight management computer. That includes the runway length, the runway slope, if it is ice, dry, or wet, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air. We're gonna have this way using the flaps and the horizontal trim stabilizer, the takeoff speeds, the V1 reloaded, and the V2, which is the actual takeoff speed. So we're gonna have the horizontal tail trim stabilizer. I'm gonna show you that. Also how to use it manually, and the speed of the aircraft, the airspeed commanded automatically or manually using the airspeed select knob in the autopilot flight director system panel. So we're gonna create the route. You can see here we have already created like a few minutes ago using The flight management computer here. You can see the units here. We created a route. You can see the waypoints we use, the data, the takeoff, also the calculations about the takeoff. So we have stored in the flight management computer has stored all the data. That includes the airports and the runways, runway length, for instance, as well. Other data like the seats and the starters, other instrument departures, the waypoints, the horizontal and vertical navigation fixes for the aircraft is stored inside the flight management computer database. All the data for flying the aircraft from climb, from takeoff, climb, cruise, descent, and approach and landing. So we're gonna have all these included in the flight management computer database and then uploaded to the flight plan when we select the waypoints for flying the aircraft. So we're gonna select the departure airport and runway, the seats, the SATA range for the departures, the horizontal and vertical navigation fixes for the initial climb of the aircraft, on the intermediate waypoints and fixes for climb, then descent and approach, and then the stars and starter terminal arrival waypoints and fixes. And we're gonna have the ILS localizer, the frequencies tuned automatically or manually. So it's gonna be tuned automatically if we select from the flight management computer all the data for the destination airport and runway. We're gonna have, in this case, it's the same airport that we have selected for departures. So we're gonna have the ILS localizer, the horizontal localizer, and the vertical glide slope tuned automatically using the flight management computer input or manually using the radio management panel. So you're gonna see how to do either way. I'm gonna show you both ways if we have time. Also, this is gonna give also the data to the autopilot flight director system panel for the LNAV and the VNAV functions of the autopilot and flight director system panel. You can see here these two switches take all the data from the flight management computer for flying the aircraft in the automatic mode using this data for the later on vertical navigation of the aircraft. We're gonna follow this purple line in the navigation display with the star waypoint. So we have waypoints in the from the flight management computer uploaded, and other board station ILS localizer, NDBs, and ADS. So we're gonna have also, I'm gonna show you after that the autopilot and flight direct. Before that, I'm gonna show you also we have in the navigation display the display of the terrain, as I told you, the weather. With the terrain, you can see also the lakes and the rivers. You can see other aircraft using the transponder, the ADSP and ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic controller receives from other aircraft. Generates the display of other aircraft, where they are located, their direction, altitude difference from our own aircraft, their airspeed, and whether they climb or descend. And this generates the TICA system, the traffic collision alert system advisories. You can see in the navigation display and primary flight display. So I'm gonna show you also how to use the transponder, the ADSP and ADC transmitter receiver, the transponder for that. And then I'm gonna show you the autopilot and flight director system panel. I'm gonna show you the autopilot engage and disengage, switch the auto throttle left and auto throttle right, engage and disengage, switch the flight director, engage and disengage, switch. We have the airspeed select knob. We can select an airspeed in nautical miles, knots, or Mach speed, and select the modes for that command the engine's thrust rating or rotation speed of the fan. So this is done automatically. You can see here, I'm gonna show you in a couple of minutes. The airspeed select knob. We can set also the thrust levers for the airspeed by moving the thrust levers forward enough. You will see the airspeed commanded here, the thrust actually. The thrust rating, you can see it takes a couple of seconds for the engines to spool up or spool down from the actual to the commanded target thrust. So this is the airspeed selectors right now, and we have the modes around it. You can see also the heading guidance, the airspeed guidance, the vertical rate of climb descent of the aircraft, and the altitude. And we have also the roll localizer and the approach for the auto run function. So you can see also here we have the N1, which is the low speed starters, have the low pressure compression turbine of the turbo fan, which is engine, the left and the right, the takeoff limit, the exhaust gas temperature, the fuel on board. You can see also the N2, which is the high speed starter, and have the high pressure compression turbine of the turbo fan, which is engine, left and right, the fuel flow per engine per hour, 1000 kilograms or 1000 pounds, oil pressure, oil temperature, quantity, and the vibration of the N2 stage. The engine also the bleeder here, you can see the pressurizer display with the outflow valves here. You can have the cabin pressurization system, also the fuel on board, some other systems. So I will continue now with the autopilot flight director system panel. I explained you about the N1 and the N2. They are displayed in the upper and the lower aircraft identification controller system display. You can see the engine rating. So when you select the airspeed command from the airspeed guidance, the autopilot flight director system panel, this gives the command to the engine's FADEX. We have FADEX installed in the left and the right wing engine, the gearbox. The FADEX are the full authority electronic control computers. One is filter engine, 12 channel redundancy, controls and monitors. If one channel fails, the other takes over, controls and monitors the engine data using the upper and the lower aircraft, like the N1, which is the low speed starters, have the low pressure compression turbine of the turbo fan engine, the exhaust gas temperature per engine, the outflow valves pressure from the 5th and 9th stage. Also the N2, which is the high speed starter, and have the high pressure compression turbine of the turbo fan engine, the fuel flow per engine per hour, 1000 kilograms or 1000 pounds, oil temperature, oil quantity, oil pressure, and the vibration of the N2 stage of the engines. Also you can see here, I'm gonna show you now also. So I'm gonna show you also over here. You can see I'm gonna show you also the flight controls after that. So the autopilot and flight director system, as I told you, commands the thrust, the airspeed guidance. So we select an airspeed in also nautical miles. We select the modes, the flight level change, the airspeed, the auto throttle with the speed, and the climb continues. So the navigation with this command, the engine thrust rating, like the N1, or the engine power rating. From takeoff, climb, cruise, descent, and approach and landing, we have the engine thrust commanded automatically, depending on the configuration of the aircraft in flight and the altitude of the aircraft in flight. What we need to do also, we can control this manually. I'm going to show you how to use manually the thrust levers for the engine thrust rating and adjusting the airspeed this way. So we have two main modes, like in the takeoff and climb, we have the fixed thrust. We have maximum continuous thrust, which is a fixed thrust mode, in which case the airspeed is being adjusted by varying how fast the aircraft will climb to the target altitude. This is done using the horizontal tail fin stabilizer position as the airflow of the jet stream of the aircraft, as the aircraft flies, and the airflow around the wings. This generates this command, and also we have the elevator position. So we also have, when the aircraft is descending, we have again the fixed thrust mode, the idle thrust, and then again the airspeed is being adjusted by varying how fast the aircraft will descend again to the target altitude by varying the horizontal tail fin position, attitude, like pitch up, nose pitch up, or nose pitch down, and the elevator of the horizontal tail again. So we have also, when the aircraft is flying horizontally, like in the cruise level or in approach and landing, we have the variable thrust mode, in which the airspeed is being adjusted by varying the thrust produced by the engine. We also have the bang angle limit, the heading select node, the heading hold switch, the vertical rate of flight and speed of the aircraft mode, the VS mode, and the flight path angle mode, the FPA, which determines the trigonometric angle increase the aircraft will climb or descend, the steepness of the trigonometric angle it climbs or descends, the altitude select node, the altitude hold switch, and the vol localizer for the Lszh localizer approach, and the approach switch for the autoline function of the Boeing 777-300 ER. So now I'm gonna start showing you maybe the flight controls. I use the side stick to control the flight controls of the aircraft, like the horizontal. We use the control column and the yoke in the Boeing 777. The yoke that includes the control column and the control wheel control the elevator up and down, pitch up and pitch down using the elevator, and the ailerons and the spoilers for bound roll using the control wheel, also the rudder pedals for directional left and right yaw steering. So I'm gonna show you now I'm gonna show you here inside you can see how I control the yoke. So now I'm gonna show you also how I use the side stick here for controlling the yoke in flight. So there is direct input between the side stick I use and the flight controls for the Boeing 777-300 ER. So I'm gonna show you now this. You can see here we have the side stick I use to control the flight controls of the Boeing 777. You can see here we have full control. We can climb like this, we can descend, we can make turns to the left like this, turns to the right. You can see how fast it moves. It's directly there is the side stick deflection is proportionally to the side stick deflection is proportional to the yoke deflection. So both sides, also the left and the right, are interconnected and they move the same way. So also we have the rudder pedals here for directional steering between the left and the right yoke. We also have the nose wheel steering, and we have the thrust levers like this. We can move the thrust forward while we are in flight, and use also the flight controls simultaneously. So you can see we can climb, descend, bungle left and bungle right, and use the thrust levers. Also we have the horizontal trim position. We can use the horizontal trim like this. So you can see the horizontal trim, nose up and nose down here. Pitch attitude in flight, pitch up and pitch down like this, and see where the horizontal trim of the horizontal tail is positioned. We have also the aileron trim here and the rudder trim. I'm gonna show you later. So you can see also the engines again as I move the thrust levers forward like this. So this actually is thrust. Now I'm gonna show you also the outside view. So now we're gonna have the outside view of controlling again the side stick and the flight controls. Then I'm gonna come inside for the rest of the systems and make the engine start demonstration after that. So you can see I'm gonna make the engines system explanations. So we have now the outside view, the flight controls again. So you can see we can climb like this, descend, make turns left and make turns right. Also the rudder pedals like this, left and right, the vertical stabilizer. So You can see how fast again the input is. The horizontal tail, like this. So now I'm gonna come inside the cockpit, show you the instruments, the displays, the overhead panel of the systems of the overhead panel, like the electrical, the hydraulic, the fuel system, the engine auto start, the cabin pressurization, the pressurizer. I'm gonna show you a little bit now the overhead, and then the systems. I'm gonna make an engine start demonstration, set up the flight management computer, the route, on the flight plan, and then make a complete flight. You're gonna see the takeoff, climb, cruise, and approach, a full flight with this aircraft right after this systems explanation. Thank you very much for joining and staying tuned for this video until its end. I'm Thomas Hatsios, the German makeup company flying the Boeing 777-300ER jet aircraft in night flight. So I'm gonna now continue the systems. So I'm gonna come here. So you can see inside the cockpit, the overhead panel, we have the electrical, as I told you here, the left and the right engine, IGT, the backup generator, the APU, the flight control computers, the ADIRU, the air reference unit, the hydraulic system, here the pumps, the engine driver and the pressurize from the air, the fire extinguishers, the passenger oxygen, the rammer turbine, the fuel injection. We get down some fuel inside, the fuel tanks, left wing, right wing, center tank, crossfit valves, cabin pressurization, and the bleed air system, and the wing and engine on the ice. So you're gonna see all these systems. I'm gonna start the engines later. So you can see now we have here the displays. We have the primary flight display. You can see the airspeed selected with purple, the altitude selected, and now the airspeed indicated, the barometric altitude, the artificial horizon width, the speed tape, the altitude tape, and the vertical rate of climb and descent of the aircraft. Over here, the pitch altitude, you can see 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 30. Pitch altitude of the aircraft as it flies. The nose pitch altitude, like this, up or down below the horizon. The flight mode annunciator with the autopilot and auto throttle. So when the aircraft might be actually pitching up, but might be actually descending, so you have to pay attention to all the instruments, like the vertical rate of climb and descent here to see if the aircraft climbs and descends. You have the magnetic heading and track, you can know. We have also the axis here, the meters, hectopascals. Over here you can see, so we have the pascals, the meters. We can select other values here for the systems here display. So we're gonna have the autopilot, the auto throttle left off. You'll see the auto throttle left off, the auto throttle right off, like this. You'll see the auto throttle right off, like this. So we have the auto throttle right now off. You can select the flight director on and off quite easily. So we have the airspeed max, or indicated airspeed or Mach, not Mach. We have also the flight director. We can turn off the flight director. The mode will be disarmed like this. We cannot arm the mode with the flight director off. We have to turn it on. We have the LNAV, the VNAV. We can disarm this. So this turns off the modes. We can select on airspeed for takeoff, ground, and initial climb here. This will be displayed here in the primary flight display, as you can see. Also we have the bang angle limit here. The heading select no, we can select a heading for here. We're gonna select the heading of the runway we have for takeoff. You can select and deselect like this, and also the altitude select no. So we select airspeed like this, altitude, heading, hold, flight level change. So we have the target airspeed, target altitude with the flight director, flight level change speed, not the autopilot yet. So I'm gonna show you in the autopilot connected. Also here again, you can set magnetic north pole here or true north pole like this. You're gonna see 1 degree magnetic or true. Now it's the true north pole like this. For navigation purposes, using this switch, I'm gonna set the magnetic or geographic. So we have also the M nav, the V nav, the vertical rate of climb descent. We can set the hold on the other side, the altitude instead of the airspeed. You can see the whole flight line here we're gonna use for takeoff. So we have now the airspeed selected, target altitude, heading, hold altitude, and the modes here. So we have also the autopilot on like this. We can select the autopilot. We're gonna connect the autopilot. So you can see here we have the flight line. You can see where we're gonna take off using this runway, the runway length, the extension. We're gonna climb here through these waypoints, cruise through here and come back for landing. We're gonna descend after the climb here. So we're gonna follow this flight line route here. You can see the whole of it, how far it goes over here down to this waypoint. So we're off away. So we're gonna have an aircraft coming now for landing. It's 2,700 feet here. You can see the terrain, the scan from the radar. The aircraft is here, 2,700 feet. So we go now for the rest of the modes. We have the autopilot on now. As you can see, heading, hold, altitude, target airspeed, target altitude. This mode now is the autopilot on. We're gonna set a couple more modes, nav, maybe VNAV, flight level change also we can use, and altitude with the VNAV also commanded. You can use VNAV and altitude, hold, and then flight level change and altitude, and hold again. You can use also this mode which is for the vertical rate of climb descent of the aircraft. You can use the trigonometric angle in degrees, like -3.5 degrees. You will see the aircraft descend below or above. You can make it a climb or a level off. So we have -3.5 degrees. You will see here -3.5 degrees pitch altitude are requested here. So we have the pitch altitude, this line is gonna be a descent below the horizon. You can see heading, hold, flight path angle here, and the VNAV, target airspeed, target altitude again. So we have another VNAV from the flight management computer. Now we're gonna use the climb. gonna be like plus 3.5 degrees. You can see plus 3.5 degrees here. It's gonna be a climb. Target airspeed, target altitude, heading hold, flight path angle. Again, you can use the vertical rate of climb and descent, but before that I'm gonna show you also. I forgot to mention this. We have the pitch altitude. Now is gonna be a climb here between the 2.5 and the 5 degrees. You can see the purple arrows here. So this is the mode for climb now, and we have also vertical speed. I'm gonna use vertical speed like this, minus 3,500 feet per minute. So we're gonna have here minus 3,500 feet per minute. You're gonna see the descent rate, vertical speed. So this you can use for descending. You're gonna have to follow this line here, this mark, the minus 3,500 feet. So you're gonna see the needle moving down and the aircraft descend. Also, we can use the other way. We can use for climb like this. So you're gonna see the plus sign now, plus 3,500 feet per minute, and we have it here, plus 3,500. Vertical speed is enough. Target airspeed, target altitude, and the target rate of climb is gonna be this purple mark again from this takeoff altitude elevation. So we have the aircraft in front of us now. It's closing in. We can scan the range closer now, the range of the navigation display and the radar, also in the transporter. So we'll see the aircraft is plus 2,600 feet here. It's moving between the C114, this waypoint here, and the Ilsloc, very close, and the TRA, this triangle. So it's closing in here for this runway, as you can see, for our own runway, this airport. You see the navigation display is coming down to the airport for landing. So this is in front of us right now. This aircraft is coming in. I'm gonna follow that. We have also the Lszh localizer here. You can tune the approach also for the autoland. So the Lszh localizer, if we switch here, you will see the warlock. That also includes the Lszh localizer. So we have now the heading hold localizer, the Lszh localizer here are the frequencies that I told you, the ITL 136 gave me Lszh localizer. So we have also the speeds, and you can see the Lszh localizer, this middle for horizontal navigation purposes, and the vertical glide slope also tuned. Now we have the traffic here, the aircraft coming in. We have to look 1 knots closer. Over here in the navigation display, so you can see the aircraft is coming in for landing. We have spotted. You can see the runway direction. The one beside us is gonna land to the next runway. So it's plus 1,300 feet above the elevation. It's 5 nautical miles away, and it's closing in for our airport. So you can see it's blinking. We have it closer and closer. So I can show you also the autopilot. It's 2.5 nautical miles away, so we have time. We'll show you the autopilot disengaged. We press this out the switch. You'll see the warning. The autopilot is disconnected like this. So reset, press this switch again, up, in, set the autopilot, show you one more time. We press this out, you see, and we have the aircraft is coming in now, the one we spotted here. So we have over here the display with the yellow and the warning, the traffic. So here we have the aircraft we were following in the navigation display. So it's coming in for landing like this. You can see just landed. So we still have the aircraft here, the mark and the traffic, the warning just went out. So we're gonna use again this, the autopilot disengage, engage it again. So we're gonna disengage the autopilot using this switch here, the autopilot disconnect switch. So we have the warning again and the warning here, autopilot disconnected. We press one more time, engage, press it one more time, disconnect, and confirm the disconnect action. Second disconnect, confirm. So we have also, I'm gonna show you the rest now of the systems. I'm gonna show you, we have here the thrust levers. We can see we can modify moving the thrust levers forward, disarm. We have the speed brake extended only when the thrust levers are idle. You can see the speed brakes here up and down like this. So this is the speed brakes now extend. So we go back inside, you can see the speed brakes only extend, the thrust levers are at idle. If we extend the speed brakes and move the thrust levers forward, the speed brake retract. If we keep the thrust levers forward, we cannot extend the speed brake, we have to move them back. Also, if we move these thrust levers, the thrust reverse, the speed brakes retract automatically, and we have over here the thrust reverse that opens the outflow valves and the bypass here of the engine. So this is how we disarmed it. Again, this reverses the flow of the air, and we use it only after touchdown in landing or in a rejected takeoff. So we close the thrust reverse. We have also a couple more switches, the takeoff ground here and the auto throttle disconnect. This switch disconnects the auto throttle here from the thrust system. So we use only manual after we disconnect the auto throttle in flight. So we can move the thrust levers forward. You will see the engine's rating here, as I told you before. The N1, the left and right engine, the low speed starter is the press compression is 200 engine, the takeoff limit green. As you see, it takes a couple of seconds for the engines to pull up or pull down. At this stage, the outside exhaust gas temperature, pressurizer from the left and the right engine. Bleeder N2, high speed starters, high press compression turbine with the turbo fan with the engine, fuel flow per engine per hour, oil pressure, oil temperature, oil quality, radiation of the engine stage of the engine. We have the fuel on board, total temperature of the fuel, the flap setting. You can see we use the flaps to increase or decrease the surface area of the wings like this, retract or extend. You will see where the flaps are placed here. You can see also we have the landing gear extend and retract here, some other warnings in the upper ACAS. The indications, the start bias display, the landing gear extend and retract, the landing gear speed, the alternate gear, the lock override, some other terrain override, the auto brake and the flap limit displayed. So we have also the horizontal pitch stream, as I told you. This is the horizontal tail over here. So you're pitching up and pitching down the aircraft balances using the pitch stream. Here you can see the pitch stream of the horizontal tail. Positioning, the green band is for takeoff and for flight. You can also use these pit trim tabs here, the normal and the alternator. Use the automatic trim from the autopilot and flight director system panel. Also, we have a failure of the CODR hydraulic system, which are also pressurized by air. We're gonna have a failure of the auto trim from the autopilot, so we have to open this garbage switch and disconnect the auto trim function, the CNDR hydraulics. You can see the stub from normal to cut out. We have also the few fire extinguishers for the left and the right engine, the fuel flow to the left and the right engine, the fuel control over here, the fuel valve. So we have also the radio communication panel, the transponder, the terrain and weather radar, the rudder and the aileron trim here positioning. You can see the degrees of position, the rudder and the aileron trim, the parking brakes up and down. So you can see we can always have manual pit trim like this if we disconnect the automatic trim. So now we have to go over here in the overhead upper panel. So I will show you now how to use the overhead upper panel. So now we have reached the point I'm gonna show you the overhead upper panel, how to use all the systems: electric, hydraulic, fuel system, pressurizer, engine auto start system, rammer turbine oxygen other system, the ADIRU, the air data inertial reference unit. I'm gonna show you all these things, gonna make the engine start demonstration, make the aircraft flying from takeoff, climb, cruise, descent, approach. So stay tuned, a few more minutes we have now this process. So you can see here we have these switches are for disconnecting the hydraulics from maintenance to the ground. We have the circuit breakers panel. We're gonna set here the flaps 15 degrees for takeoff. You can see the flap set, the position here in the display. We have also the autopilot display, one more view, nicer view. And hold on, I'm gonna show you now the ADIRU, the data inertial reference unit. I'm gonna explain later. The thrust asymmetry compensator, the primary flight control computers, the battery, primary APU generator. So I'm gonna use the auto start for the APU. We have the left and the right engine IDG, the integrated drive generator that produce alternate fuel, 120 to 100 volts. 400 Hz frequency. Also the batteries, direct current. We have the window heat, the passenger oxygen, the rammer turbine for backup. Also hydraulic pumps here. This is the hydraulics, the electrical, the fuel system, the engine start, the pressurizer. So you can see now the warnings, and we have we lost some systems. We have alternate flaps, and we lose the stabilizer, flight controls, flaps, hydraulic pressure, RC and R, LC and R, and also the landing gear extender retract is gonna have some problems. So we reset the hydraulics back to on. This will cancel the warning. Then back to the auto position. We have also here, you can see the cargo fire and the APU fire, the electronic engine control for the engine, normal and alternate mode, the auto start. You can set the auto start on and off like this. The fuel jettison, we can dump some fuel in flight if we arm this to make the aircraft lighter for landing. Also we have the fuel system, left and right wing, center tank, crossfeed valves, balance fuel between the left and the right wing using the crossfeed valves, wing and engine gun the eyes here. Cabin pressurization, we have manual, use the outflow valves for climb and descent, open and close, select landing altitude, automatic, I'm gonna use the auto. So we have also the lighting system, the windshield wipers, And here you can see the bleeder from the left and right engine. We need bleeder here also from the APU to start the engine. So you're gonna see what happens if we turn off all the bleeder. So this is the main overview of the overhead panel. So we go now for the rest of the system. I'm gonna show you also the display here. I'm gonna show you also we need to make the auto start the engines. So this is the last section now. CDU control display unit. So we have over here the display menu, you can see. So we have the engine, the status, you can see the hydraulics, the APU is running, and the oxygen level, the checklist, normal menu, resets, no normal menu, if we have a failure of a system, communication, navigation, synoptics, the doors are closed and the cabin can be pressurized, the landing gear, the temperature of the brakes and the pressure of the tires, the electric system, left and right IGZ, the great dry generator, 180, 200 volts, 400 Hz alternate current. You can see the APU also, where the electric goes, and the main battery voltage, and barrage charging discharge. The hydraulic system, the left and right engine hydraulic system, the air pressurizer C1 and C2, 3000 psi each system, where the hydraulic system fluid goes. Over here the throttle valve, the fuel system, left wing, right wing, forward and aft fuel pumps, the low and high pressure fuel valves for the left and right engine, the crossfeed valves can feed either wing engine with either wing tank or pump if we have a failure. The APU is fed from the left wing using the DC motor. The center tank is empty with the yellow crosser. You can see the forward and the aft pumps are working. Also the low and high pressure fuel valves, the total fuel on board and how much fuel in the left and the right wing. The minimum fuel temperature also below which the fuel freezes. The air, the left and right wing, the APU, we need the backflow from the APU to start the engines. Also some hydraulic fluids, wing and engine anti-ice, air conditioning, ventilation. We need also the last system, the flight controls. Here you're gonna see they're all working nice and freely like this. So we have the flight controls movement here this side also. So it's displayed here, all the flight controls are working normally. Okay, also the aircraft, the stabilizer tree. So we go back to the engine over here, and here are the Ilsloc cockpit, and we have to make the engine start here the demonstration. We cannot turn off both left and right fuel flow. We're gonna have a reset overhead panel. We have the engine auto start system on. We're gonna see here engine auto start, engine start down over here display. As you can see, the engines are starting down. Also here you can see the right and the left wing. The spinners are moving because we have pressurizer, so we need to start only the fuel flow like this, both left and right wing fuel flow. So we're gonna have the auto start now coming in, and the fuel is increasing. You can see both right and left wing spinners are increasing, and we are ready for takeoff. We have set the aircraft, the flight plan is ready, so parking brakes disconnect, and we go for the runway for takeoff. Advance the thrust levers like this. We take the runway clearance from the air traffic control, and we start moving the aircraft. So we taxi into the runway. We see the runway is open for us. We take a runway clearance. Align with the center line here. So parking brakes again. Set the Lszh here. And the outside view where we are and where we're going. So we have like advance the thrust levers forward, disarm the parking brakes and go. So we have about 20 more minutes. V1, we rotate, we start the rotation smoothly like this, and V2 we take off. So we have a beautiful takeoff, very nice, very smooth. The computer frame is also, so we have positive rate of gear up, positive rate of climb, gear up, and you can see we are 1,800, 1,900, 2,000 feet above the ground level. The airspeed 200 knots, 4,500 feet above the sea level, declining up. You can see all the information here displayed. The airspeed, the stall speed, the flaps limit, and the needle here we're climbing, the terrain also, the radar, and the flight plan. I'm gonna have a nicer maybe flight plan view like this. So we can start turning now until the turn. So we have 18 more minutes for the video to end. Keep climbing. So we need also this manual. Maybe the flaps up to increase the airspeed limit. So you can see where we're climbing now. Over here we have again the indications, also the airspeed here after climb, the autopilot. So everything is set. We keep climbing. So we're gonna have now a nicer view of the aircraft as we turn around here. So we have this beautiful view of the aircraft. You can see we're flying with 600 kilometers, 650 kilometers an hour, 250 meters per second. 250 meters per second, 250 kilometers an hour. You can see the beautiful view of the Switzerland here, all of it, the Zurich, and also the galaxy here. We have the beautiful star sign. So now we're gonna start turning back to the flight plan route over here. So we have this beautiful view of the aircraft, the Boeing 777-300ER. I believe the most beautiful of the Boeing airplanes. Very nicely aligned. So we have to turn a little bit steeper here as we climb. Maybe we need more thrust. More flaps again. Also use the first waypoint here. So we're gonna have to cross through this waypoint here. With the plaza, you can see some aircraft flying around us. You can see we are very close also to the stall speed, so we need to increase the airspeed a little bit, leveling off. So we're gonna use maximum takeoff thrust now. Increase the airspeed. Yeah, almost very close. 30,000 feet. So we're cruising for the next waypoint now, over here. We need to level off to increase the airspeed a little bit. And we are very close So we have the France, this side is Germany, in front of us. So we need to pitch up a little bit. We cross 33,000. When we cross 33,000 feet, we have the centers now for display. So we reach the altitude, we have the centers and the contrails, the frozen vapors from the aircraft stage. So we are almost reached 600 kilometers an hour with spacecraft view for tonight. You can see the Germany, the Bayern Munich in front of us, the France on this side, and the Switzerland on this side. Also we have the lake here in the Switzerland. So Germany very close. And this is the beautiful view with the galaxy of the frozen vapors. You can see the aircraft as it cruises with the frozen vapors behind it. the Boeing 777. So we are gonna start turning back home now. We're gonna retract also the flaps, increase the airspeed to reach the lake over here, very close. You can see as we turn, we have also over here turn around. We have again the view of the galaxy here. We almost reached 980 kilometers an hour, 300 meters per second. This is a spacecraft view with the galaxy over here, 35,000 feet above Switzerland. So I hope you like it. The Boeing 777 300ER for tonight. So we're going now home, back to our base at the airport. So we have again visited here with Switzerland into Germany, and the Alps, also the galaxy, the beautiful galactic views here. You can see how we cruise, very nice. You can see the star signs here. We go back inside. You're gonna see the difference now. We keep climbing a little bit, and we have like 10 more minutes for this flight. So we need to level up here. We're going manually again. As you can see, the airspeed we have advanced, and we need to level up here manually, so we can pitch stream a little bit. Also we can connect the autopilot for some aid. So now we have the autopilot connected. We're gonna have automatically the altitude followed and the route. The next waypoints also we need here. Follow this route now. Direct waypoints with the autopilot. You can see the airspeed now is 331 knots at 35,300 feet per Mach 0.77. Also this beautiful view again from outside, and we have 8 minutes left. We have again no frozen vapors, 980 kilometers in cruise with the autopilot, and we're gonna start now descending on the aircraft. So we're gonna select a lower altitude now, and decrease the airspeed a little bit, and we're gonna increase the rate of descent. We're gonna have automatic now on. Also the speed brakes. You can see. We start the descent path now. Also the idle thrust automatic here. You can see the thrust rating, and the autopilot, the command here, and we keep having the cruise, the chemtrails here. The frozen vapors. So we keep descending with a lot of airspeed now. There's a lot of gears now. Have 6 more minutes to go. Keep going with the autopilot. You can disarm actually the autopilot like this, going manually. So you can settle. The flaps as we keep descending, and we have 4 more minutes left for this flight. Keep turning. The wall localizer also. So we're gonna have the Lszh localizer. We're gonna have the view also here of the aircraft Flught as we proceed. So we're gonna have so we're gonna slow down like this, and we are increase the descent rate. So we are inside the Lszh localizer. We have idle thrust, manual thrust, the Lszh localizer here. So the Lszh localizer. Here we are. Touchdown. the aircraft in the runway, parking brakes and full reverse. So we have full reverse thrust like this, and we made a very beautiful landing here. As you can see, very beautiful, very professional landing, center line. So you can see the nozzle here, the landing gear, everything is safe. The aircraft is standing up just the way it should be, like this. We have both the nozzle here and the landing gear behind it. All the wheels are safe, as you can see. So you can see the back and the forward wheels over here.